Hello everybody. This is Professor West and welcome back. As many of you know, I create these videos for my students to try to help them explain some of the topics that we're covering in the various courses, and I put them online so that they can use them, but also so that anybody else that's interested in computers can also use them. So anyway, the segment that we're going to cover today is the basic components of a computer. And I have a few pictures of computers sitting here. The bottom left one's a standard desktop PC. The bottom middle one is an Apple PC. And the bottom right is what's called a supercomputer. Notice there's a guy standing down there at the end. That shows you how big this thing is. And all these rows, these are all part of one computer. Supercomputer, you might expect NASA to have a supercomputer. You might expect the Department of Defense, air traffic control, I would assume. Our nation's power grid probably has a supercomputer running it. But they're incredibly fast and incredibly powerful. And that's pretty much all I'm going to say about supercomputers, because when you break it down, every computer has the same parts. The supercomputers just have a lot more of them. So what is a computer? A computer is an electronic device that is used for storing and processing data according to instructions it receives from a program. I realize that's a pretty vague description. And there's a reason for that. Because today, pretty much everything that you see or do that's electronic is a computer technically. My digital watch is a computer. My TV is a computer. The computer that I'm typing this on right now is a computer. Laptops, desktops, smartphones, iPads, iPods, they're all computers. If you like to play games, your Xbox is a computer. Your PlayStation is a computer. If you have a refrigerator that has one of those display screens where it can tell you when you're out of ice and all these other stuff. Some of them even have Wi-Fi. Those are computers. Smart cars. There's so many. Pretty much everything is a computer, it seems like. But the interesting thing is, when it comes down to it, they all have the same components. And that's what we're fixing to talk about. Here are the main components that are in pretty much every computer everywhere. They all have a central processing unit. And don't worry about what that is right this second. That's the next slide. I'll get to that. They all have to have memory. They all have to have storage devices of some kind. They all have to have input and output devices. And they all have to have some way to communicate. So let's dive into a central processing unit, the CPU. We also call this the processor, and sometimes we call it the brain of the computer. Think about how your brain works for just a second. If somebody asks you, hey, do you want to go get something to eat now, or would you rather work out right now? Your mind starts considering all the different options, all the different reasons, and you start, making your choice. And maybe I'm hungry right now. Maybe I'm not hungry right now. Maybe I'm tired right now. I've been working and I want to take a few minutes before I go to the gym and work out. Whatever. Your mind goes through all these considerations and comes to a conclusion. That's exactly what the processor does. You give it the information, and based on whatever software is there, it makes a decision. And it can create reports. It can do whatever you need it to do. So let's think about, I'm going to talk now about bits and bytes real quick, because a bit and a byte are the basic units of everything. They're like atoms, how atoms make up your body, bits and bytes make up everything in the computer. So, if you've ever seen one of those old Frankenstein movies where Dr. Frankenstein's trying to bring his creature to life, you always see them say, throw the switch, and they grab this big giant switch and they click it and lightning forms, and they throw another switch and the table starts moving, and they throw another switch and something else happens. And that's what a switch is. And oddly enough, our computers today are still based on switch technology. Now, there's not physical little switches for you to flick every time you need something. These are all inside your computer, thank goodness. And they all boil down to either the switch is on or it's off. And in computer language, we represent that with ones and zeros. It's called binary code. As the name implies, a switch, it's like a light switch. It's either on or it's off. There's not an in-between. So when you walk into a room and you turn your switch and your light comes on, that would be a 1. When you turn it down and it goes off, that would be a 0. And I know sometimes people try to argue, oh, what if you use a dimmer and blah, blah, blah. But the truth is, it doesn't matter. This light is either completely off or it's on. And it may be dim, it may be on a little bit, but it's still on. So switches are the same way. They only have 2 states, off and on, and they're only represented by 1s and 0s. So I'm going to talk just for a minute about it so you have some idea. But check this out. Right here I have the representation for the capital letter C in binary code. It's 01, 00, 00, 11. So imagine 8 switches lined up on a wall, and I say, hey, show me the capital letter C. And you turn the first one off, you click it down, turn the second one on, you click it up, off, 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 on. That would be the letter C. Then I say, okay, well, show me the lowercase w. Well, now you got to turn the first one off, the next 3 on, the next one off, and the next 3 on. This is exactly why we don't do binary in the real world. That would drive people crazy if every time you imagine trying to type a paper and your teacher tells you, oh, I want a 10-page paper. And every time you want to type one letter, you had to actually type 8 1s and 0s. That would be so crazy. It would never get done. So we have our computer set up to automatically translate. When I type the letter C, it automatically translates it into this. When I type the lowercase w, it automatically translates it into this. When it's time to display it on the screen, it translates it back. But the computer has to have it like this in order to be able to function. Now, each of these numbers, each of these 1s and each of these 0s is said to be 1 bit of data. This is important because all 8 of them together make 1 byte of data. So 1 byte of data is 8 bits. This reason I'm telling you this is because everything that we do in regards to data storage, data transmission, we start talking about speeds and how much they can hold and all that stuff. We're always talking about bits and bytes of data. So it's important that you understand that that's what this is. So for example, I like to use this example. This is really good. If you were a millionaire, that means you'd have at least $1 million. So you could say milla would be million. Billa would be billion. If you're a billionaire, you'd have at least $1 billion. Trillion would be a trillionaire, and so forth. And with that in mind, kilo means 1,000 and mega means 1,000,000. So a kilobyte is said to be 1,000 bytes. A megabyte is said to be 1,000,000 bytes. A gigabyte is said to be 1,000,000,000 bytes. And a terabyte is said to be 1,000,000,000,000 bytes. Now, let me stop right there for a second. A kilobyte is said to be 1,000 bytes. I said it that way on purpose. Technically, it's actually 1,024. And it has to do with how memory is chunked together in groups and blah, blah, blah. But most people ignore that and just say 1,000. So if you wanted to be technically correct, you could argue this way. But as far as the world's concerned, if you say a kilobyte, most people just think 1,000 bytes. And notice I said to be about each of these as I read them, because they're all that way. A megabyte's actually 1,024 bytes. A gigabyte's 1,024. It's just how the world works. So it's not really that important, this extra little bit. In very rare cases, it's important if you're doing something programming wise and you need that extra little bit. But as far as just talking in the real world, just round it up and everybody's happy. Okay, memory. I told you the CPU is like the brain of the computer. Well, memory, also called RAM, which stands for random access memory, is the place where all the actions occur. It's also called the work area of the CPU. If I were to hand you a piece of paper with a pencil and I say, what is 123 times 42? You write it down on your piece of paper real quick. That's your brain, the CPU, telling your hand to write on the paper, which would be the memory. That's the workplace. That's the work area. That's where everything's getting done. And I went ahead and drew up a quick graphical representation of memory over here. Now, there's not a true representation ever, but this is close enough. You get the point. So let's say that these are memory addresses down this side here. The truth is your memory address would be really long because there's like a billion of them in there, and they all have to be uniquely identified. But don't worry about that. For now, I'm just going to use this shortcut. So 2005, I put in all the ones and zeros to represent the capital letter C. In spot 2006, I put in all the ones and zeros to represent the capital letter O, then MPUTER. So if I were typing computer, the computer would translate it and store it into memory like this. And when it came time to tell me what was there, it would output everything from 2005 to 2012. It would translate each one, and then it would say the word computer. Everything I typed here, memory also referred to as RAM, each of these were translated into ones and zeros and stored in a spot in memory. And now this picture, the slideshow, everything's being stored there. That's how computers work with memory. So, here's the thing. Take that same piece of scratch paper, and let's say I've given you a number of different problems, and you've solved each one, and now you're starting to run out of space. And now I ask you, well, what's 111 times 249? Well, just by looking at this little picture here, there's not really enough room to do that. So you're actually going to have to try to squeeze it in here maybe, or maybe over here. And the point is, now you're going a lot slower than you were when you had the whole piece of paper. And that's actually what happens with your computer when it starts slowing down all of a sudden. Have you ever been working and all of a sudden your computer gets so slow that you click on something and it sits there and sits there and sits there and then finally does it? Most of the time, that's because your memory gets full. And this is why we tell, if you go to some kind of a computer repair place, one of the first things they recommend is adding more memory into your computer. Memory is relatively cheap, it's very, very fast, and it's really easy to install. So if you're doing more than what your current memory can handle and your piece of scratch paper is full, then adding more scratch paper was the easiest way to fix that problem. And it's a whole lot cheaper than buying a new computer. One problem with memory is that it's volatile. This means that everything that's in memory right now, if I lose power to this computer, that's all going to be gone. If I've saved it to my hard drive, then it's saved there. But everything that I haven't saved is gone. And that's the drawback to having the faster memory, being able to run everything. And this is also why we save a lot when we're working on stuff in the computer world, because you don't want that to happen. I know I mentioned it before in other tutorials, but we have a saying in the computer world: save early and save often. This little presentation I put together here, I probably saved it 40 times as I was making it. Every time I added a few things onto a slide, I'd save it. And then that way, if something did happen, I wouldn't lose it. Okay, storage devices. This down here, take a look at the bottom, and you'll see a picture of a hard drive. This is a Hewlett-Packard hard drive, I believe. And this picture beside it is the same hard drive, but without the cover, because I wanted to show you the inside of it. Actually, it looks like several CDs. And these are called magnetic drives. These are non-volatile, which means anything stored on your hard drive when you turn the power off will be there when you turn it on. Unless, something really weird happens, like your hard drive crashes, but that's a whole different thing. But for the most part, everything saved on here when your computer loses power will be saved until, you have power again and you can do work on it. All of your operating system, everything that you're doing, every program on your computer, every document you've ever written, every program you've ever written, every picture you've ever taken and saved on your computer, it's all saved onto your hard drive. Next, we have optical disc drives. These are CDs, DVDs, Blu-rays, and so forth. And I have a picture of a Blu-ray disc here, in case you haven't seen what a Blu-ray disc looks like. Looks an awful lot like a CD or a DVD. And lastly, we have USBs. USB stands for Universal Serial Bus. and it's this little one over here on the bottom right. We also call them flash drives or jump drives. You plug this little end that's sticking out here into a port on your computer that looks like it would take that, and then you can save a tremendous amount of data onto these. Some little ones like this may hold 50 gigabytes of data, which is quite a bit for a little thing like that. But this allows you to save something onto it and take it and plug it into a different computer and have access to it. It's also another way to back up your work. I have a number of very important things on my hard drive, and I also saved them onto a jump drive like this. So if anything ever does happen and my hard drive crashes, I don't lose this important stuff. I put that into a fireproof box, and every once in a while I add to it. And that way I know it's always safe. Check this out. Here's some things they've started doing with some of these flash drives lately. And they make them look like toys. They can make them look like just about anything. But notice the one thing they all have in common is this little square part that sticks out that goes into your computer. That's how you plug it into your computer, and then there's a little part in here that saves everything. But I just wanted to show you some fun little things you can do. And these flash drives are actually extremely inexpensive depending on how much you want to be able to save. You can buy them for $4 or $6 that'll hold maybe a gigabyte or two, and then as they start going up, I have one that holds 128 gigabytes. So that's a lot, and it just depends on your needs. But I just wanted to point out that there's a lot of different choices here. Input and output devices. An input device is any device that allows you to put something into the computer. Your keyboard allows you to type into the computer. Your mouse allows you to click and point into the computer. A scanner allows you to scan documents into your computer. An output device is the exact opposite. It allows something that's in the computer to come out. This could be a monitor. Everything that you're watching right here is my presentation that I'm making being output onto your monitor. If you were to print something, then that would be output. You're also listening either on speakers or headphones or something. That's an output device because, again, it allows it to go from your computer out to you. And if we didn't have input and output devices, then the computer would be relatively useless. There wouldn't be a point in having it. Communication devices. Okay, in the 90s, and some of you may not remember this, so if you've seen any cartoons from the 90s or anything like that deal with this, you may be familiar with a dial-up modem. There was a time where you hit a button and it would actually make a call over your phone line. It would call your local internet provider, and then you would start hearing a series of horrendous screeches, and it would go and eventually you would be online. It translates data or transfers data up to 56K is what they always claimed. I very, very rarely, I don't think I ever seen one actually transmitting anything at 56K. More than likely, it was usually around 35 or 40. A K, we talked about kilobytes a while ago. I said KB on the other slide, but a lot of times they just say K. Or sometimes they'll just say M or whatever. But so this was 56 kilobytes of data supposedly being transferred at a time. I've seen them go as slow as 10 or 8. But that's very, very annoying because it takes forever for a single web page to load, especially if there's pictures on it, because pictures take a lot more. Next, we have digital subscriber lines, DSL lines. These still connected over the telephone lines, but they were about 20 times faster than the old dial-up modems. And but you still plugged it into your phone line, and it just had a constant connection. Next was cable modems. There was a time where if you had cable coming into your apartment, a coaxial cable where you could get HBO and Cinemax and stuff, you would use the same cable and hook up your modem to it, and you could get internet over your cable. Next would be the NIC cards, the network interface cards. These allow you to plug in a wire into your computer wherever you're at, and be able to connect to the internet. And then there's the wireless networking, which is the most popular today. If you open up your laptop at home, there's a good chance that if you have a router, that it just connects. You don't have to plug a wire into it to connect. And that's a wireless connector, wireless networking. So, and they're now considered pretty quick also. So that's it, guys. Every computer will have most of these basic items. They don't all have networking, but they do have some kind of communication. Otherwise, they wouldn't have a point in being there. Your refrigerators, some of them now actually do offer Wi-Fi. But even before they offered that, they were still had computers in them because they had digital screens that did different stuff. But the point is that if you're connecting, here's some different connections. The point is that all the computers have the same basic components, the same basic parts that make it up. And now you know a little bit more about them. So I hope you found this informational and enjoyable. And make sure to check out some of my other videos. I put one up called Tips to Becoming an Awesome Programmer, where I tell you things that you can do to help increase your own abilities as a programmer. I have another one that's called Programming Code Tips, where I walk you through a bunch of things that you can do to your code to make your code better, make it stand out. And then I also have series of videos for Java and C#, and I have one for Zybooks if you're a student that takes any of the classes that use Zybooks. And I have more that's coming, so check back. And if you would, subscribe to me. I need all the subscribers I can get, people. So subscribe to me. Alright, anyway, I hope you enjoyed this, and I hope to see you in the next segment.